Hello students, welcome to Educate. In the previous video, we have discussed about colligative properties. I hope all of you already know what is colligative properties. Even though I am just giving you in the short. What is colligative properties? Those properties of the solution which only depend on the relative number of moles of solute particles and do not depend on the nature of solute or solvent particles. That is called colligative properties. Those properties of the solution which only depend on the relative number of moles of solute particles and do not depend on the nature of solute or solvent particles that are called colligative properties. But what we have discussed in the colligative properties previously, in those cases we have not considered about the dissociation of particles or the association of particles when the solute dissolve in liquid. Okay, in this case, that means in the previously whatever we have discussed, that was valid only for those particles which do not dissociate or associate when dissolve in solvent. Like that, for the glucose, when you dissolve the glucose in water, then those whatever we have studied, those concept will apply. Here also that will apply, but some additional information there is. That is, when there will be dissociation of particles or the association of particles when solute will dissolve in solvent, then what will be the relative lowering of vapor pressure, the elevation in boiling point, the depression in freezing point, as well as the osmotic pressure will be. About that we will discuss in abnormal molar mass, or here about that we will discuss by the help of Hoff factor. Okay, I have told you that when glucose dissolve in water, then no need to consider about the Hoff factor, because the glucose do not dissolve in when dissolved in water, do not dissociate or do not associate, because glucose do hydrogen bonding with water particles, and that's why glucose solubilizes in water. Let's see here about the abnormal molar mass and the Hoff factor. So, what is Hoff factor? Firstly, Hoff factor here, there is when there will be association of particles or the dissociation of particles. About abnormal molar mass, this one is introduction just like that. Here, the Hoff factor has been given. What is Hoff factor? So before that, here also given about the association of acetic acid. What is here? Just let's see, consider about KCl. When you dissolve water in KCl, or when you dissolve KCl in water, suppose here this liquid water, you have dissolved here 1 mole KCl solution. KCl, water is there. If you will have to find out here 1 mole KCl in 1 kg water. So what earlier, according to your earlier concept, what would be delta TF? Delta TF, that means depression in freezing point, will be equal to Kf into 1, that you would do, or delta TB, that equal to Kb into 1. But actually what happened here, when you dissolve KCl in water, the KCl dissociate into K plus and Cl minus. That means when you have dissolved 1 mole KCl in 1 kg of water, then there will be 1 mole KCl will form 1 mole K plus and 1 mole Cl minus. So KCl dissociated when you have dissolved in water. So total number of moles of solute here will be 2 mole. Actually, this one when you had calculated without considering that KCl will dissociate, but KCl has dissociated. So actually depression in freezing point will be equal to Kf into 2 and elevation in boiling point will be Kf into 2. Okay. So here just you consider delta Tf dash, delta Tb dash. What happened here? Delta Tf, observed colligative property is delta Tf and your calculated colligative property is delta Tf dash. In the same way, the observed elevation in boiling point will be delta Tb and your calculated value of elevation in boiling point will be delta Tb dash. So Van-Hoff factor will be here what you have observed, that is here Kf into 2 observed colligative property upon calculated colligative property Kf into 1. So that is here 2. So one of them is Van-Hoff factor will be observed colligative property upon calculated colligative property. So this one here. Second one is total number of moles of particles after association or dissociation. So here KCl, one particle has dissociated into 2 particles. So after dissociation or association, number of particles here, KCl, here is dissociation. So after dissociation, the number of particles is 2 mole and before dissociation, the number of particle is 1 mole. So upon 1, that means 2 here. So Van-Hoff factor is total number of particles after dissociation. Here is dissociation taking place, about that we consider. So total number of particles after dissociation, that upon total number of particles before dissociation, that is 2. So either you find out by observed colligative property upon calculated colligative property, or the total number of moles of particles after association. In case of association, in case of dissociation, dissociation. So total number of moles of particles after here dissociation, that upon number of moles of particles before dissociation. That is same 2. Third one is normal molar mass upon abnormal molar mass. Watch out here. The molar mass of KCl, and when you will find out the molar mass of KCl by the help of colligative properties. So here obviously here the molar mass will be average of twice of this one. Suppose this molar mass will be 39 here and 35.5. 74.5. So here the molar mass will be 74.5 upon 2. Obviously, molar mass as a whole you will have to find out, because whatever be the weight, that will be weight for 1 mole, and what you will find out the weight, that will be for 2 mole. So its molar mass, when you will calculate, that will be half of the molar mass of KCl. So that's why Van-Hoff factor will be normal molar mass upon abnormal molar mass. So there is 3 formulas for Van-Hoff factor. One is normal molar mass upon abnormal molar mass. Second one is observed colligative property upon calculated colligative property. And third one is total number of moles of particles after association or dissociation, that upon total number of moles of particles before association or dissociation. Okay guys, so if you get confused in the examination, by that concept you can escape out from the confusion. That is, here molar mass will be, here normal molar mass here is greater and abnormal molar mass is less. Observed colligative property here will be greater and calculated colligative property will be less. Total number of particles after association or dissociation, here when dissociation, then that will be greater, and when there will be this one, and let's see about when association will take place, which we have discussed. That was about when there be dissociation of particles, when the solute will dissolve in solvent. Now we will consider about when there will be association of particles, when the solute will dissolve in the solvent. Let's see here, one example has been given, that is for acetic acid. You might have studied in the chapter of aldehyde, ketone and carboxylic acid, and if not studied, then you will study in the chapter of aldehyde, ketone and carboxylic acid, that the lower member of carboxylic acid, the lower member of carboxylic acid associates when dissolved in aprotic solvent. The lower member of carboxylic acid associates when dissolved in aprotic solvent or in vapor phase. When the lower member of carboxylic acid will be in vapor phase or when that will dissolve in aprotic solvent, then they will dimerize. What is dimerize? What is dimerization? So dimer means when two particles will combine together and will act as a single particle, then the molecule will be called dimer and the process will be called dimerization. As in case of polymer, a number of molecules combine together and act as a single molecule, and that process is called polymerization. In polymer is when a number of simple molecules combine together and act as a single molecule, that is called polymer. In the same way, dimer, when two molecules will combine together and will act as a single molecule. One term was also aprotic solvent. Very simple it is, aprotic solvent. As the name indicates, A and protic. Protic means proton, like protic acid when you tell. That means the acid which give proton. Proton means H plus ion. H plus ion considers as proton because hydrogen contain only one proton and one electron. The hydrogen atom contain one proton and one electron, and there is no neutron in hydrogen atom. So after losing one electron, the remaining part is proton only. So H plus considers as proton. The acid which give H plus or the proton. H plus means proton. The acid which gives H plus, that is called protic acid, like HCl. Here HCl gives H plus ion. HCl dissociates into H plus and Cl minus. So HCl is a protic acid. Okay. So that same as protic acid, there is protic solvent. Protic solvent means the solvent which contain H plus ion. And aprotic solvent means the solvent which does not have the proton. So, like benzene, benzene has no proton. Benzene has no proton, so that's why benzene is aprotic solvent. Benzene is aprotic solvent. Let's see here why the acetic acid act as dimer. This one acetic acid molecule and another acetic acid molecule here. What happened? The oxygen of this carbon will be hydrogen bonded with this hydrogen, and the hydrogen attached to this oxygen will be hydrogen bonded. And you know, hydrogen bonding is the strongest intermolecular bonding. Intermolecular bonding means bonding between two molecules. That is, one of the example of bonding between two molecules is van der Waals bonding, dipole-dipole bonding, hydrogen bonding, and among that one, the van der Waals bonding is the weakest bonding and hydrogen bonding is the strongest bonding. And here, two hydrogen bonding is between this oxygen and this hydrogen, and between this oxygen and this hydrogen. There is two hydrogen bonding. So, it will be too much difficult to separate one molecule from another molecule. This acetic acid, when you dissolve in aprotic solvent like benzene or like kerosene oil, like petrol, then these molecules will associate together and will act as a single particle. If this dimer and another dimer here, this molecule here also hydrogen bonding, here also hydrogen bonding. Between this dimer and this dimer, there will be van der Waals bonding. Van der Waals bonding. Magnitude of this van der Waals bonding will be also high, not too much compared to that of hydrogen bonding, but normally, you know, greater be the molecular weight, more be the magnitude of van der Waals bonding. So, this van der Waals bonding will be also high and they will exist in liquid phase. This one, that is here when the acetic acid will dissolve in aprotic solvent like benzene, like petrol and any other compound, okay, which is non-polar or which do not contain H plus ion. Okay, so that is here association. So when particles will associate, then normal molar mass will be greater. Particles will associate here, so normal molar mass will be greater. And if all the particles will associate, then normal molar mass here twice. So normal molar mass will be greater, abnormal molar mass will be less. No, sorry, normal molar mass will be less, abnormal molar mass will be greater, because normal molar mass same as natural molecular weight of acetic acid. This one is normal molar mass. When you will calculate the molar mass of this acetic acid, that will be normal molar mass, and this one is abnormal molar mass. This one is not a molecule. So it is abnormal molar mass. Now, when dimer will form, when two particles will combine together, then the number of particles after combination will become less. So, in that case, number of moles of particles will be less and the total number of particles before association was more. So, total number of moles of particles after association upon total number of particles before association, that will be. And after association, number of particles will become less. So, elevation in boiling point or depression in freezing point, or the value of osmotic pressure, or relative lowering of vapor pressure, that value will become less, because greater be the particles, greater be the number of particles, more be the elevation in boiling point, or depression in freezing point, or relative lowering of vapor pressure, or the osmotic pressure. And here, after association, the molecular weight calculated will become greater, but the number of particles will decrease. That's why the elevation in boiling point, depression in freezing point, relative lowering of vapor pressure, and the osmotic pressure will be less than calculated. Okay, that was. Now let's see here. In the 12th board examination, question will not ask that write the formulas, but if you will not know what is actually the Monta factor, then how you will solve. In the same way, for 12th board exam, for IIT main, advanced, as well as for NEET examination, you should have this concept. Then only you can solve the numerical questions asked in IIT main, advanced, as well as in NEET examination. Which type of questions asked in IIT advanced, IIT main, as well as in NEET examination, that we will discuss separately. Right now, I am only giving you about the concepts of the chapters. About the which type of questions asked, I shall make the video separately. Let's see here. So, in the 12th board examination, the questions frequently asked is the numerical, and this numerical question is too much important. This one. Here also given here this table, and don't bother about this one, this table. I tell you, you can predict by yourself also. The Monta factor value given. And you may think that have to mug up. No need to mug up. You can predict by yourself also. Let's see how. Like NaCl here, that will dissociate into Na plus and Cl minus. So 1 mole of NaCl will give 1 particle of NaCl will give 2 particles. That is 1 particle of Na plus and 1 particle of Cl minus. So 1 particle gives 2 particle. That's why Monta factor 2 upon 1. So that will be 2. Same here for KCl. Same here. KCl, that will dissociate into K plus and Cl minus. 1 particle gives 2 particles. So, Monta factor 2. Same MgSO4. MgSO4. So, that will dissociate into Mg2 plus and SO4 2 minus. 1 particles give 2 particles. So, Monta factor will be 2. Same K2SO4. K2SO4. 1 particle of K2SO4, when dissociate, there will be formation of 2 particle of K plus and 1 particle of SO4 2 minus. So number of particles after dissociation will be 2 and 1. Here 3. So Monta factor will be 3. This one. Need to mug up? Very simple. Now let's see here. And about this one, no need. Just like that has been given. Now let's see about this question, which is highly important, and that is this question here. Given 2 gram of benzoic acid dissolved in 25 gram of benzene shows a depression in freezing point equal to this much. Molar depression constant for benzene has been given, and it is asking the percentage of association of acid. The percentage of association of acid, and it forms dimer in solution. Okay. Now let's see here. 2 gram of benzoic acid dissolved in 25 gram of benzene. Depression in freezing point, what has been observed? That has been given 1.62. This 1.62 is the depression in freezing point which has been observed. Molar depression constant has been given here, and it is asking percentage association of acid if it forms dimer. So let's see here, observed colligative property has been given. So when you will calculate what will be the depression in freezing point without considering the association of the benzoic acid, then what will be there? Depression in freezing point. Now what's the observed colligative property? Divide that calculated colligative property which you calculate, then you will get want of factor. And another one, you know, the want of factor is also equal to number of particles after association or dissociation, that upon total number of particles before association or dissociation. Okay, so let's see here. Firstly, observed, let's see, calculated colligative property. Calculate the colligative depression in freezing point without considering the association of particles. So you know already delta TF equal to KF into molality of solution. So that will be equal to molar depression constant has been given 4.9 Kelvin kg per mole. So 4.9 Kelvin kg per mole. That into molality of solution. Molality of solution is number of moles of solute. So number of moles of solute here is benzoic acid upon weight of solvent in kg, and weight of solvent here has been given 25 gram. Convert into kg. So that upon 25 upon 1000, that much kg. So firstly calculate the number of moles of benzoic acid. So number of moles of benzoic acid, that will be equal to weight of benzoic acid given, that upon molecular weight of benzoic acid, that upon molecular weight of benzoic acid. So molecular weight of benzoic acid here. So molecular weight of benzoic acid how much? C6H5COOH. That is 122. So number of moles of benzoic acid will be number of moles of benzoic acid H5COOH, that will be equal to weight given 2 gram upon 122 gram per mole. That means 1 upon 61 gram will cancel out here, mole. Okay guys, hope this one be clear for you. You have not felt any difficulty till here. So because what I have calculated the number of moles of benzoic acid that has been dissolved in 25 gram of benzene. So what will be the number of moles of benzoic acid? First of all, that we have to calculate. That will be equal to 0.016, that much mole. Number of moles of benzoic acid will be 0.016 mole. So molality of the solution will be here 0. This one. So molality delta TF will be equal to KF is 24.9 Kelvin kg per mole, that upon number of moles is 0.016, that much mole, that upon weight of solvent 25, 4 ja 100, so 40. So 1 upon 40 kg. This is the main division line, this one mole division line, main division line. So 40 will go in the numerator. So that will become 24.9 Kelvin kg per mole into 0.016 into 40 mole per kg. Kg cancel out, mole and mole inverse will cancel out. Okay, this one till here, no any problem. Watch out again. Into here is 4.9. So here what is this one is 4.9. Calculate this one. Delta TF calculated will be that much 3.136 Kelvin and delta TF observed is 1.62 Kelvin. So let's see here next process. Here I think you have done. Now let's see here. So want of factor that will be equal to observed colligative property, that is observed colligative property upon calculated colligative property. Observed is 1.62 Kelvin, 1.62 Kelvin, and you have calculated as 3.136 Kelvin, 3.136 Kelvin. So how much is coming? Calculate. Observed colligative property is 1.62 and calculated colligative property is 3.136. .516 is the value of want of factor. Okay, so first of all here I have calculated the value of want of factor by observed colligative property by calculated colligative property. Since what's the depression and freezing point has been given and I have calculated the value of depression in freezing point without considering the association of particles. So want of factor I have calculated. Now we will discuss about the association of particles. By considering the association of particles, now we will calculate we will compare the want of factor by considering the association of benzoic acid. Benzoic acid here C6H5 COH that has been associated to form C6H5 COOH whole twice. When you have taken benzoic acid, when you have just dissolved the benzoic acid in benzene, then total number of particles, suppose 1 mole here, so that will be 0. At T, what happened? Suppose X particle of benzoic acid has associated. Suppose X particle of benzoic acid has associated. So how much benzoic acid left without association? That will be 1 minus X. So here 1 minus X. Now watch out here, 2 particles of benzoic acid, 2 particles of benzoic acid associate to form 1 particle of its dimer, 1 particle of dimer C6H5 COOH whole twice. 2 particles form 1 particle. So X particle will form how much? 1 by X particle. So at T, number of benzoic acids left unassociated will be 1 minus X, and the number of dimers of benzoic acid will be X by 2. So total number of particles after association, what is here? 1 minus X, there will be particles of benzoic acid 1 minus X. There will be 1 minus X particle of benzoic acid and X by 2 particles of dimer of benzoic acid. So total number of particle will be 1 minus X plus X by 2. That will be 1 minus X by 2. Okay. So Bantoff factor, that will be equal to number of particles after association that upon number of particles before association. So Bantoff factor will be 1 minus X by 2 upon 1, and Bantoff factor you have also calculated 0.516. Okay, so Bantoff factor is 0.516. 1 same here. So 1 minus X by 2 will be equal to 0.516. Okay, 1 minus X by 2 is 0.516. So X you have to calculate. So X by 2 will be equal to here. This X by 2 will come this side and this 0.516 will come that side. So that will come 0.483. So X will be equal to 3 to the 6, 8 to the 16, carry 1, 4 to the 8 and 1, 9. 0.966. That is here. Percentage association means when you will take 100 particles, then how much particles will associate? That will be called percentage association. So percentage association will be when you have taken 1 particle, then 0.966 particle has been associated. So when you will take 100 particle, so multiply into 100 by 100. So that will be 0.966 by the traditional method upon 1 into 100. That means 96.6%. So 96.6% particles percentage association of benzoic acid will be 96.6%. Okay guys, clear here? So this question asked in 3 marks in 12th board examination, and there is high probability of asking this question in IIT main as well as in NEET examination, and in IIT advanced this question will ask in modified form. Okay, so now let's see. I hope very comfortably you could solve these questions. Now let's see, proceeds on another one. Now let's see here about how to solve this question. This question is very easy to solve. I am telling you the hint how to solve. You will have to do the calculation. I shall tell you how to solve this question easily. Just you have to solve the questions. Calculate that. Here is 0.6 milliliter of acetic acid having density 1. This one is dissolved in 1 liter of water. What is here? The volume of acetic acid has been given and the density of acetic acid has also been given. And that acetic acid has been dissolved in 1 liter of water. 1 liter of water means 1 kg water, because density of water is 1 kg per liter. So mass of 1 liter water will be 1 kg. The depression in freezing point has been observed is that much, and you will have to find out the want of factor and the dissociation constant of acid. So let's see here, mass of acid, density, you know, mass by volume. Density is mass by volume. So density of acetic acid, density of acetic acid will be mass of acetic acid. Density of acetic acid, that will be mass of acetic acid upon volume of acetic acid. So how much mass of acetic acid there is? That means here given volume of acetic acid which has been dissolved. So you can calculate the mass of acetic acid dissolved in water. So mass equal to density into volume. Mass equal to density into volume. So that will equal to here. Density has been given in gram per milliliter and volume has been given in milliliter. So directly you will have to multiply the density with the volume. The mass you will get in gram. So that will be equal to 0.6. It is milliliter into 1.06 gram per milliliter. 6.36 milliliter cancel out, so that much gram. 6.36 will be the mass of acetic acid. So now number of moles of, because you will have to calculate molality, because depression in freezing point equal to Kf into molality of the solution. So Kf has been given, so you have to calculate molality. To calculate molality, you need number of moles, and to calculate the number of moles of acetic acid, you need to calculate the mass of acetic acid. So firstly, I have calculated the mass of acetic acid dissolved in water. So number of moles of acetic acid will be equal to 6.36 gram, that upon molecular weight of acetic acid you will have to find out. That means 6.36 gram upon 60 gram per mole. So now 6 1 is 6, 6 is 36. You can calculate here, decimal take out, this one 20, gram cancel out. Now 6 1 is 6, 1 2 3 30, 6 1 is 6, 0, 6 is 36. 1 2 3. So that means that is 0.106, 0.0106, that much mole. So that is here calculated this one, and mole inverse that much come. Now molality will be equal to, now this molality will be, calculate this one, 0.0106 is number of moles is 0.01. So that will be equal to Kf, that will be Molality number of moles is 0.0106, that upon 1 kg. This is mole, and Kf has been given. Here not given. Kf of water is 1.86. No need to mug up. Most probably in the examination that will give 1.86 Kelvin kg per mole. That will be Kelvin kg per mole. So mole inverse and mole will cancel out. Kg will come here. This kg cancel out. So Kelvin will left. So now 1.86 into 0.0106. Multiply that. So after multiplication, that will become 0.0197. That much Kelvin. Delta TF is that much. Now want of factor. So observed colligative property upon calculated colligative property. So want of factor will be observed colligative property is how much? The depression is equal to 0.0205. So it is in degree Celsius. Guys, keep in the mind, change in temperature in degree Celsius will be equal to change in temperature in Kelvin. How? I shall tell you later on. How that is? Because that is change. So delta TF that is equal to want of factor will be, that is here 0.0205 Kelvin. Also you can consider this one. So that will be equal to 0.0205 divide Kelvin, that divide by 0.0197 Kelvin. Okay, calculate that is. That comes 1.041. So that is equal to 1.041. Want of factor is that much. Okay. Now you will have to calculate the dissociation constant of acid. So let's see here carefully. Watch out this one carefully. Benzoic acid. First of all, I am telling you how to solve this question, and then after I shall tell you change in degree Celsius will be equal to change in Kelvin House. So this one benzoic acid. So that is acetic acid. So that will be, gives 1 mole of acetate ion and H plus ion. This one done. Then after is, suppose number of moles here is n. So then after you can do also. So want of factor, number of want of factor you have calculated. So first suppose here initially you have taken number of moles of acetic acid as x. You have taken the number of moles of acetic acid as x. So it will be here x you have taken. It will be 0. It will be 0. After that, at t equal to 0, that much. At t, what happened here? Suppose from here you have taken y mole has been subtracted, or degree of dissociation you take 1 minus y. So x into 1 minus y you can consider. So it will be xy. It will be xy. So want of factor will be that will be equal to xy into xy, that upon x into 1 minus y. X cancel out. X cancel out, and 1 minus y will be approximately same. So xy square will be that much. So want of factor is how you have calculated 1.04 this one. Then after you can also calculate. Then after you can also calculate this one. X you have calculated. Then after the concentration of acetic acid, the concentration of acetate ion, and the equilibrium constant you can find out. So concentration of acetic acid, concentration of acetate ion, and this one you can find out very easily. Okay guys, I hope this one is clear for you. Even though if not clear, then you may call to me. You may ask in the comment box here. Acetic acid here, so number of moles suppose n. Here 0, 0. Then after want of factor will be here, will be n into 1 minus x. Total number of particles will be this one, addition of all of them. So that is here. So value of x has been calculated. So acetic acid concentration N into 1 minus X, and acetate ion NX, and that of hydrogen ion will be also NX. So equilibrium constant has been calculated. Very easy question it is. You can solve very easily. Let's see the another concept. This one done. Now let's proceed about the some important questions of this topic. Of exercise, which one is more important? About that we will discuss here. Summary, very easy. These questions, when you have, if you will listen my lecture carefully, very easily you can solve these questions. This question is also very easy. Next point here goes on the next point of this question. This question is very easy. You can solve very easily. 1.6 question. That's I hint you how to solve. And by that hint, you try to solve by yourself. If you could not solve that question, then after you ask in the comment box. Let's see how to solve here. What's the hint here? There is sample of Na2CO3 and NaHCO3. So there will be a sample. Its weight will be how much? Given 1 gram. 1 gram there is. So suppose number of moles of Na2CO3 will be X. So NaHCO3, that will be equal to 1 minus X. So number of moles of Na2CO3 you calculate, that will be equal to X upon molecular weight of Na2CO3. That upon 106, and that of number of moles of NaHCO3 will be 1 minus X upon, here how much? 23 plus 1, 12. And it is equimolar. So X upon 106 will be equal to 1 minus X upon 84. That is the number of moles, this one. So X upon 106 is equal to 1 minus X by X upon 106. That will be equal to 1 minus X upon 84. So 84X equal to 106 minus 106X. So comes this side. X equal to 106 divided by 190. You can calculate this one. How much is coming? 106 divided by 190. 106 divided by 190. That came 0.557. 0.557. 0.557. That much in gram. So number of moles of Na2CO3, that will be equal to 1 upon 0.557. It is this one, because number of moles of this one, this acid will be Na2CO3, weight is 0.557, 0.557, that much gram upon molecular weight of this one. So 106 gram per mole. That much you will find out number of moles of Na2CO3. Number of moles of Na2CO3 you calculate. So number of moles of NaHCO3, that will be also equal to 0.005. Now let's see, you do the calculation by yourself also. Might be there I do some mistakes anywhere due to the lack of concentration, because I have to speak also and will have to teach you also. So you can calculate this one by also. So now let's see. Na2CO3 will react with HCl. So there will be formation of 2 moles of NaCl, H2O and CO2. And NaHCO3 when react with HCl, there will be formation of NaCl, H2O and CO2. So 1 mole react with 2 mole. So here 2 mole of HCl required and here 1 mole HCl required. So total number of moles of HCl required will be 0. This one into 3. So that will be number of moles of HCl required to react will be how much? 3 into 0.005, 0.015. Then after is here molarity is given 0.1. So that will equal to number of moles of HCl that upon volume of HCl. So 0.1 here and it is 0.015. So volume of HCl you can find out. How much volume of HCl? That you can find out. What's the volume you will calculate? That would be in liter. Okay guys, very easy this question is, not so much easy. It will be injustice to tell. That's very easy. But if you will apply your brain, then very easily you can solve this question. And remaining questions you could solve by just watching my videos. If you have watched my videos carefully, then no any question there be which you could not solve. Even though if you could not solve a particular question, then you ask in the comment box and definitely I shall reply about that questions. Okay guys, it's all for this class. In the next class we will discuss about electrochemistry. Thank you, Team Educate.